Here we have another word problem. Let me explain what's going on. We have a figure, fortunately. We have a parabola y equals 9 minus x squared, an inverted parabola because of the negative coefficient. So let me write this as y equals 9 minus x squared. Notice that it's symmetrical about the y-axis because it's an even function. Replacing x by minus x doesn't change anything. Now we have a rectangle here, ADCB, or ABCD, bounded by the parabola and the x-axis, just as in the figure. And we have to figure out the length of the side CD, or DC, to maximize the area of the rectangle. This rectangle has a certain area. I'll call the area, let's say, in a different color. Say it's A for area. And let's see now. We need to figure out some points. So the point B, let this be x, this distance from here to here. So this is, the point B will be the point x0, and A will be the point minus x0. Now the point C has the same x, but its height is given by y, which is 9 minus x squared. I think I have all the information I need to compute the area. The area is going to be my dependent variable, that's clear, because that's the one that we have to maximize. Now, I know that the area is going to be base times height, and the base, well, this bit is x, this bit is x, and this bit is y, but y here is equal to this. So if I put all this into the formula, I've got that A, the area, which is base times height, which we said is 2x is the base. The height is y, which is 9 minus x squared. And this, in fact, gives us the area in terms of x. If I expand, this gives me 18x minus 2x cubed. And that's basically it for the geometry part. We have a in terms of x. And now we go on to the calculus, where we differentiate to find the maximum, hopefully. So a prime equals 18 minus 6x squared. And to look for a maximum or minimum, we let a prime equal 0, which gives us that 18 minus 6x squared equals 0. So clearly x squared equals 3. And since x is positive, we get x equals the square root of 3. And we want to know the length of the side CD. Length, sometimes I put it in absolute value, is equal to 2x, so it's twice the square root of 3. Now, all that remains to show is that we really do have a maximum here, and this we usually do with a table of increasing, decreasing. So let's make a little table. In the table I put x, a prime, and a. Here I put a list of my suspects, and I only have one in this case, and that is the square root of 3, at which point a prime is equal to 0. That you can substitute it, but that's how we got the square root of 3. And then I need a value on the left and the right. Now the square root of 3 is roughly 1.7 something, so I can take on this side 1, and on this side I can take 2, and I just need the sign of a prime. So let's see, if I put x equals 1 in here, I've got 18 minus 6 is 12, and that's positive. And if I put x equals 2 in here, then I get 2 squared is 4 times 6 is 24. 18 minus 24 is negative. This means that the function up to the point square root of 3 is increasing, and from the square root of 3 it's decreasing. So the general shape around here is like this, which means that this really is a maximum. So the area function does indeed have a maximum when x is square root of 3. What they asked us was the length of the side CD, which is twice the square root of 3, and that's the answer, and we are done.